just in case, I'm going live on YouTube. So followers on YouTube can check out our talk as well.
Okay, great.
Yeah. Okay. Do we want to wait maybe 1 more minute and then Sophia can start sharing her screen and give her talk, like introduction to the Academy?
Sure.
Okay, I think Sophia, you can start sharing yours.
Okay, great. Do you see the slides here?
Yes.
Do you see the slides?
Yes.
Okay, great. Shall I start?
Sure. Yeah.
Okay. Hi, everybody. Welcome. My name is Sophia, and I'm here on behalf of NYC DSA on behalf of the admissions team. And my job here today is to tell you a bit about our school and our programs, and to tell you what the best fit might be for you. Now, some of you have probably already enrolled, and others of you are considering enrolling with our school. So in order to address the broadest possible audience, I'm going to keep this overview comprehensive and not get too granular. If you have any questions, feel free to email me directly. I'll provide my email address at the end of this webinar. We want our participants to participate. So if you have any comments or questions, feel free to drop it in the chat box. So a little bit about our school. NYC DSA offers boot camps, professional development, individual courses, and course bundles. Our flagship boot camp is the Data Science with Machine Learning Bootcamp. And we offer that in 2 delivery formats, one of which is in person and live streamed via Zoom. And this one is full-time and 12 weeks long. We require you to attend both morning and afternoon lecture. So for those of you who prefer more flexibility, we also offer the on-demand pre-recorded full-time 16-week Data Science with Machine Learning Bootcamp. For those of you who are either full-time students or have other responsibilities on site, there is another more flexible option, which is the 24-week Data Science with Machine Learning Bootcamp. We also have now the Data Analytics Bootcamp, which allows you to, at either week 12 or week 7, because it's also offered live, in person, or pre-recorded, to transfer to the Data Science with Machine Learning Bootcamp. So this is an opportunity for those of you who want to dip your toes into data science to both make initially a smaller investment, because it's about 2/3 the cost of the Data Science Bootcamp, and then to transfer into the Data Science Bootcamp. So it offers you that bit of flexibility there. We're the only bootcamp that teaches both Python and R. Python has rightfully dominated the spotlight as the language for machine learning, but R is also very powerful and widely used. And because NYC DSA want our data scientists to be as well-versed and adaptable as possible, you'll know both and be that much more competitive in the job search. We offer 4 hands-on industry projects, and one of which is the capstone project, which allows you to work with our industry partners on industry pitch projects, which increases your visibility in the data science community. And in addition to that, you will be added to the NYC DSA blog post as a contributor, which further contributes to your credibility and your visibility. We have very robust job placement support at NYC DSA through various channels. What distinguishes our bootcamp from some of our competitors is that you get unlimited one-on-one mentor support from our industry partner alumni, And in addition to them helping you with your projects and your homework, you can actually browse their bios. And if their bios interest you and that they are currently working in a field that you want to apply to after graduation, you can schedule sessions with them that you can use to your benefit, whether it be for mock interviews or resume reviews. You can, it would be your prerogative how you want to utilize the sessions. Another channel is our career services office, where you will be meeting regularly with your career services advisor towards the latter part of your stay at the bootcamp. And because you will be updating the advisor on which positions you are applying for and which jobs you're interested in, they will be communicating these preferences to our industry partners, and you will be at the top of their list since we are advocating for you and will be forwarding your profiles to our industry partners. At the conclusion of the bootcamp, you will be added to a study group that you will then be collaborating with your peers on to polish your elevator pitches, in addition to working on sets of technical interview questions, which are widely encountered in the interviews that you will encounter as you're searching for that preferred job. We have 2,000 alumni working across the globe, and our diversity is reflected in our student body and our faculty. And we have consistently been rated on both Course Report and SwitchUp as best data science bootcamp. This is a breakdown of the dates for the upcoming cohorts. The next cohort for the in-person live streamed via Zoom bootcamp, which is full-time and 12 weeks long, is Monday, January 3rd. The one for the on-demand pre-recorded bootcamp is November 8th. And if you miss this one, then we also have an availability January 3rd. And this one is 16 weeks for full-time and 24 weeks for part-time. For the data analytics bootcamp that I mentioned earlier, there are similarly 2 start dates. The online version, which is part-time and 12 weeks long, which again allows you to transfer later to the part-time online data science equivalent, starts November 8th, and the in-person starts January 3rd. If you decide to apply with us, the admissions process is straightforward. You submit your application, we review it, schedule an interview where we'll learn more about your interest in data science and our academy. And if all goes well, we'll schedule a technical assessment, which you have 48 hours to complete, return to us, and then we'll forward it to our data science instructors who will grade it, and then you will get a decision within a week. If you have any more questions, feel free to reach out to me at this email address. We have very generous referral bonuses for those who decide to attend boot camps together in the same session, in addition to alumni referral bonuses. So reach out to me if you're interested, and I'm going to open it up for questions before we move on to our talk.
Any questions in general? Okay, if not, we can give the stage to Raúl. And if you guys have questions along the way, feel free to throw them in the chat, and we're gonna help you out. Okay.
All right, thank you. It's all yours, Raúl.
Awesome. Thanks so much, Sophia. Thanks so much, Martina. Okay, I'm going to share my screen.
Yeah.
Okay. Here we go. Is that okay?
Still screen sharing. While we are sharing, there's VG asking, could you please let us know about the, oh no, okay, the fees for the book. Okay, no, it's fine. It's fine, it's fine.
Yeah, okay, cool.
Still screen sharing though.
I'm already sharing my screen. Can you see it?
Not really.
No?
Can you guys see it? Yeah, I have a blank screen here as well.
Okay, let me give it another shot.
Yeah, that would be great.
Okay, is that better? Or do you still see a blink?
Still black. So weird.
Okay, I'm not sure what may be happening. Okay, let me try this one more time. Okay, how about now? No, really?
You wanna try to leave and join the session again?
Okay, sure.
Yeah, I'm so sorry. We are so sorry for this little inconvenience, but Raúl is gonna join real soon. Yeah, it's always something. It happens. Like we did the practice test and it worked. Okay, now it's working.
Yeah. Okay. Awesome. Okay then. So, well, hi everybody. Thank you for having me and for being here. My name is Raúl Vallejo. I'm here to talk to you today about my journey as a data scientist, starting out in the data science field and what I've learned across the years, what's worked for me, and touching upon various points such as imposter syndrome, best practices, habits, and more some things that go beyond the tech skills, right? So before we dive in, just a quick overview on the content. I'm gonna give you guys a quick background on myself. Then I'm gonna move on to how it was starting out in the data science field, in particular in a small one data person organization. Then I'm going to move on into working in a team of data scientists, a bigger team of data scientists. Then I'm going to talk to you about new teams, data science teams that are starting out. A lot of new tech companies are emerging, so that's the idea, is to talk about these new teams that are forming in these companies. Then I'm going to talk about imposter syndrome and how I managed to kind of overcome it. It's still something that's always going to be kind of present. Then I'm going to talk about data engineering, which is something that is sometimes overlooked very easily. And also about the tech, getting comfortable with the tech, with cloud computing and all of this that also can be somewhat elusive when you're just starting out in the field, right? And lastly, I'm gonna be closing with some remarks on the long run on perfecting your data science practice. Okay, so professional experience. Right now, I'm currently head of data and analytics at Ion, a mortgage loan and construction loan company here in Mexico. We're in the process of transforming ourselves into a proper fintech. Previously, I was a data scientist at Confio, a SoftBank-backed fintech here in Mexico City, which has just today reached a unicorn valuation. And previous to that, I started off my data science career at a smaller financial institution called Laudex, which does student loans here in Mexico City. In total, I've accrued over 5 years of experience working with data analytics and machine learning. And my education background is in actuarial science. My bachelor degree is in actuarial science here at ITAM in Mexico City. I specialize in applied statistics, which helped me get my foot in the door with all the machine learning things. And well, I took the 12-week in-person boot camp here at NYC Data Science Academy 3 years ago in the fall. And later on, I took a smaller, more express boot camp with Correlation One. Okay, so starting out, well, most of the time when you start out in data science, maybe you can get the chance in a company where they want to start doing data science, and when a data scientist or a junior data scientist hears that for the first time, well, that sounds awesome, right? It seems that the company may know exactly what they want, how to use data science, and who they need. But more often than not, they don't really know exactly what it is. They don't know what it's for, and they're kind of lost into who to hire. So this is very typical. It happened to me when I thought that I would come back from the data science bootcamp and everybody would applaud me and say, okay, awesome, we're going to do data science finally, and let's go, let's get down to it. And it really didn't happen that way. It really didn't happen that way. There's a lot of work that you have to do at like assuming a kind of data evangelist role in the company, explaining how data flows in the company, how to operationalize data solutions. And so that's one of the first things you can expect, right? So when you start working in this scenario where the company is only has a one data person organization, it's just this one data person that is in charge of analyses and getting data and maybe creating dashboards and reporting, and also finding machine learning use cases and all of this. The first thing that you're gonna run into is that it's going to be very hard to get the data you need, unless you're in a very big company where they have already software engineers that have built some sort of data infrastructure, centralized data infrastructure. Otherwise, it's going to be very hard to track down all the data that you need to solve or analyze a particular use case. So it's going to feel kind of like a maze, and it's pretty much like chasing somebody down a maze, because you're asking different stakeholders like questions such as how do you use this data? What data would you like to look at to make your decisions? And they kind of point you in one direction, and they may tell you, okay, I get my data through an email by this person. So you're tracking the data, you go back to its source, so that you can access and get your data directly from where it's coming from, right? You can't be depending on emails from a person or a report that's published every now and then. You have to start tracking down your data, right? So also another thing that is going to be difficult and you're going to run into is project planning, right? So in data science still is kind of a black box for most people that are just starting to use it in their organizations. So they may ask this data scientists, even though they're just starting out, well, you know, how can we can we see this huge project done? When can you give us a date so that we can start using this, you know, in our operations and start seeing the value of data science? That's going to be a very recurrent question, and it's going to feel like project planning completely in the dark. You know, you have to be careful with managing expectations so that you don't shoot yourself in the foot and promise things yet you start to realize that are more difficult than you anticipated, right? So that's one of the most difficult things, and that takes time and iterations, a lot of iterations to perfect. And it's something that is always going on, right? And thirdly, it's also difficult in general, and this is not only difficult for small organizations, but across the board, to translate insights into actions and decisions. So the first step in getting value from your data is to start making decisions based on that data and based on that insight. And sometimes it can be difficult for you to express and show that the data is telling you something and that the decision should be made based on that data. Sometimes it can still be difficult, depending on the organization, to get people to get out of the usual routine and ways of thinking and of making decisions, and instead of making decisions based on their experience and the way they've gotten to know the industry over the years, start to actually give the data the importance it deserves and the importance it needs, right? And finally, well, the mysticism around data science is one of the most challenging cultural barriers to adopting data science, and for the data scientists to start contributing value with their work in the organization. So what can you do? Well, in the first part regarding getting your data, you have to work to get a reliable data flow so that you can stop depending on data that comes from different places. So you have to track down your data and start thinking of ways of how to automate that data flow so that you can get the data that you need without going through too much hassle. And in this sense, you're kind of performing the role of a mini data engineer just for your operation. And maybe something that's run locally on your computer, or maybe you can get something working in the cloud, maybe something working with cloud storage, or maybe even something simpler like Google Drive, OneDrive, these kinds of cloud storage architectures. So that's going to be really important for your productivity, so that when a new use case comes along, well, you know what data you have, the quality of that data, and if you have to prioritize some space in your project planning to actually track down the data and get the data into your data flow. And so on the project planning part, it's really important to be mindful of all of the components of the data project, especially if you're doing this by yourself. It begins from getting the data, extracting the data, and storing the data as well. Sometimes in data science practices and most of the content that is shared on regarding data science, data is already kind of like a given. Like if you check out a few posts or videos, they tend to focus on actually working with the data once you have the data. But an important thing will be getting your data, right? Getting your data in a usable state. So you have to be mindful of those parts of the project, as well as the deployment and how you're going to deliver your insights. Most of the time, organizations that are just starting out with data science don't really have the infrastructure to host, I'd say, an endpoint where you can share a dashboard or an API, or maybe just something as simple as a report. Maybe you have to be sharing your automated insights via email or expose them using some business intelligence tool. So you have to be mindful of all of those components. And like I mentioned, you have to manage expectations like a pro. It's very difficult to be asked what deadlines and how long it will take for certain components of the job if you're you're not an expert in data storage, cloud computing, and also DevOps and model deployment, for example. So regarding the insights and translating insights into decisions and actions, consider something important that has to be considered in this is the value between analytical and operational solutions. So when you're trying to make database decisions, this is basically an analytical solution, right? So you make an analysis on the data, you get some insights, valuable insights, and you make a few key decisions that will solve the problem that you found, or that will make more efficient something that you've identified in the data. This is just the first step in getting value out of your data. The next step, and the step that really makes the value of your data explode in your organization, is operationalizing the data and the solution. So what does this mean? This means automating decisions, automating the data flow, and automating the use of the data to make decisions. This is basically putting a machine learning model into production, or just simple. It doesn't have to be necessarily machine learning. It can be just a data solution, operational, right? So that embeds itself into the operations of the company, and that way you're starting to transform your products into data-powered products. Also, when you're dealing with insights, don't forget about data visualization. Data visualization is one of the most important tools in your data science toolkit, and it's all about practice. sometimes one of my habits when I'm working with data visualizations to present this to a committee of managers or a CFO, for example, I will make the data visualization and think in my head what questions may arise, what questions they may ask me about the data, and see if my graph is actually answering this or causing more questions. And then I will iterate, make a few adjustments in the graph, and then ask myself the same questions to see if the graph actually communicates what I want it to communicate. And finally, around the mysticism around data scientists, well, identify quick wins and low-hanging fruits. It's really exciting to see when you get some insight, some really cool insight that shows that there's a particular problem with the product or with the segment of customers that maybe have a high churn rate, or in the loan industry, maybe they have a high in non-payment rate. So if you can find these quick insights, that's going to be really valuable, and that's going to start to help managers see the value of actually analyzing data this way. And when it comes to machine learning, always start with a stupid model. Don't go with the random forest and XGBoost and stacking and model ensembling. Start with the basic linear regression, multiple linear regression. This is the most explainable model and understandable model for non-technical people, and work your way up. Most of the time, a multiple linear regression model will solve the problem. Will solve 80% of the problem, and maybe the last 20% isn't really that worth it. You know, solving 80% of the problem is good enough, and you can move on to something else. Okay, so that's regarding starting out in data science and in the context of a single data person. Now I'm going to talk about working in a team of data scientists, which is it's quite different. You know, the dynamic in which you work with the other data scientists, and the dynamic in which you contribute to the code base and to working models is quite different. You know, but in general, it's really fun. It's awesome to be able to work with data scientists that are equally as technical as you, and you can even throw around some data science jokes like the one on this tweet. I really like this tweet when I looked at it, because I kind of thought that when I got into into a data science team, I would just do models, and that was the best thing. You know, that's the only thing I want to worry about. And well, it's kind of like licking the frosting of all the cupcakes. You have to do you can't just do that all the time, right? So in teams, it's all about good practice, and good practices that everybody in the team are following, with the sole objective, the most important objective of working in a team of data scientists is to constantly deliver solid and impressive results. So every iteration with model or with a business intelligence use case, the next iteration has to be faster, has to be better, and there's a lot of good practices that you can assume in the team that will help you get there. I'm showing you guys here in on the right side of the slide, YouTube's AI recommendation algorithm, which is responsible for over 70% of the time spent on the platform, which makes it one of the most successful algorithms so far. Now we got TikTok, but it's been one of the most algorithms so far, and it didn't come from a eureka moment by some a data scientist or a team of data scientists that said, yeah, we can do this, and then we're going to change everything. It's most likely due to an accumulation of knowledge and an accumulation of good practices that that led the team to start contributing to the value to the organization in this way. So some of the good practices you can assume, and in teams, most of the time you're going to arrive there and see already these practices and policies working, and with certain tools and with certain policies, right? So first of all, model documentation. It's very surprising to me. It's hard to conceive how model documentation is very much overlooked and forgotten about. I've seen organizations where they're on the third generation of a model, and they have 4 or 5 other models in production, and none of them have model documentation. This makes it really difficult for the data science team to scale and to improve on the knowledge that they've gained when they develop the last machine learning model. So model documentation, what does this include? Model documentation includes any important EDA findings. It includes any relevant plots that might have driven key decisions in feature engineering or feature selection, and also the target feature definition. The target variable that you're going to predict. It's also important to record that so that you have a record of what the model in production is actually predicting. It's also very important to record the performance metrics. That's always paramount. There's a few tools that can actually help you automate this recording of the machine learning model that you trained and the prediction metrics, like MLflow. MLflow is a great tool that can help you with that kind of experimentation with your models and benchmarking your models. But either way, if you don't have that, you can just take notes, take screenshots, and embed it somewhere so that the next iteration on the model can take these findings and improve upon them, right? The next practice is commenting your code. That's one of the basic principles in commenting code and software development as well. This is one of the most important habits you can make, and you can start cultivating it from day one. Day one you get at the job, you start commenting your code. It doesn't have to be the most efficient code, but when people see the code that you deployed into production, or the code that you're sharing with other people in your team, they're going to see how well commented your code is, and it's going to leave a very good impression, and it's going to make other people in the team want to work with you. If you're having good commented code that is understandable by any person in the team, well, that's going to be a big difference regarding which data scientists in the team they're going to ask to help with a certain project. Also, functional programming. Functional programming is something that in data science is kind of left at the back, like in the back burner. Functional programming basically means that everything that you're writing in code, you wrap it in a function so that you can later apply the function in a single line of code, and you apply all of the back code that you wrote, right? And the ultimate step for that is actually making classes. So you can make a class for model training, a class for extracting the data and creating your training set. There are a lot of packages that already do this, but it's a good practice. When you're developing a model, you want to use functions, because when you deploy it into production, you also have to deploy the code, right? So if you deploy that same function that you used in development, well, that means the features that you're going to compute in production are going to be exactly the same. They're the same class, and they use the same functions. It also is going to make life very much easier for collaborating. So say and this is where concepts like the feature store can come into play. But say you write code to clean up a certain training set that is widely used in the company. In my case, we can look at non-payments and payments for loan clients. So if you work on code that will clean that data set, we can actually wrap it in a function, wrap it in a class, and so that way other people in the team can take a look at your class, take a look at how well commented it is. They can understand how to use your functions, how to use your classes, and that way you standardize and elevate the quality of the code, and it actually dramatically improves the agility at which the agility at which the team can start to develop new pipelines, new models, which is the ultimate objective. You know, these good practices are followed by each of the people in the team, so that the team as a whole can constantly deliver results faster and better. Finally, the last two ones are deployment guidelines. So it's also very important to document. And this usually happens just once or twice, and maybe iterated a few times depending on if the deployment methodologies and procedures change. But it's also important for the data scientists to know and understand how to package their model so that they can export it and put it into production. Sometimes the process of putting it into production isn't that easy. Most of the time, you would like it for it to be as simple and as easy as a git commit, git push, and then maybe merging it into the master branch, and that's all the deployment process. And it's not always that simple. Finally, model monitoring is extremely important, because it's where the data science cycle, the machine learning development cycle comes full circle. Something that happens more often than not, and is actually very common. And right now, there's a few players that are actually raising capital because they're solving this problem. Is monitoring the features that you're getting at in production. So maybe you say you develop a model on your computer or on your data platform, and suddenly you deploy the model into production, and you kind of see that the model isn't exactly making the decisions that you thought it would. You computed a certain, say in loan origination, you computed a certain approval rate of the loans, and you're starting to see that the approval rate is actually much lower or much higher than you expected. So that it's important, it's a good practice, and it's increasingly getting standardized. You have to monitor the features that the model is getting and the model is computing, and also the predictions that it's computing, so that you can understand if there's any feature deviation, any feature that isn't properly computed. Maybe it was due to data leakage in your model development. That it's surprising when it happens, but it does happen, and it sometimes doesn't. You don't realize that you have data leakage until you deploy your model into production. So that's very dangerous. That means that your model is not going to get the data yet you were going to get, and so your predictions, your prediction metrics aren't going to be real with the model in production. So model monitoring is also very important. Okay, so now moving on to new data science teams. So right now, for example, here in Mexico City, the fintech scene is really booming, as well as in Latin America, Brazil, and Colombia. And so there's a lot of new data science teams that are emerging, and these companies are starting to accrue and gather a lot of data science talent. And there's a dynamic that is very different to teams that are already more established in bigger organizations. So what I'm showing you here is a hierarchy of needs of data science. Basically, it's a pyramid where the foundation is what data engineering is responsible for. Collecting the data with depending on the use case, logs, sensors, user-generated content maybe, and then storing the data, which is part of the reliable data flow, getting infrastructure and pipelines in place, and storing both structured and unstructured data. And finally, on the data engineering side, also these pipelines are in charge of cleaning, prepping the data so that it's so that the data scientists and other stakeholders in the company can use reliable data, as this concept of one source of truth. And so later on, that's when data science comes into action. So data science starts to take this data and perform analytics on it, calculate KPIs, metrics, aggregations, dashboards, and it starts. That's kind of like the first level of value that I was talking about at the beginning. Later on, you can start applying more sophisticated data solutions using machine learning, A/B testing, and experimentation, and further down the line, some deep learning as well. So with regards to new teams are going to be very much in the mix of the roadmap to success for the roadmap to success for these new companies. So these new companies are starting out. They want to be, you know, tech companies, database companies, and so data science now plays a new, very important role in the roadmap to success. And you can see it when they start asking, you know, when can we have the data lake, when we have the data warehouse, when can we start looking at the first machine learning use cases. All of this is a contributor to actually, you know, going out and finding investors, getting a Series A, getting a Series B. And so what you can expect in this kind of team is, well, first of all, wearing different hats in a much bigger scale than when in a one-person data organization. In this case, there's going to be a lot of data engineering. You're not going to be able to just get the data very nicely, you know, in a golden platter and start working on analytics, dashboards, and other use cases. You're going to have to work on the pipelines as well to get the data in the state that you need to actually start working on the use cases that are based on machine learning and analytics. Also, cloud services and cloud computing, that's increasingly being the case for data scientists to actually learn and understand how to use and interact with these services. AWS and Google Cloud Platform, these are services that the data scientist has to know how to interact with it. It doesn't have to be the whole suite of cloud computing, but there's a few services that are key and are very prominent in the deployment of data science projects. Also, business intelligence, not always are you going to be able to get to the machine learning models on your first few months on the job. You're going to be asked to first run some analytics, maybe automate a dashboard so that the stakeholders can start to look at the data, and then based on the insights and what you are seeing and what the stakeholder is identifying also in the data, machine learning use cases are going to come up when time passes. And finally, regarding DevOps also as well, if the data science team is new, data science team is probably going to have a hand in deploying and sending models into production. So regarding the hierarchy of needs from the last slide, with new teams will have to begin at a vertical cross section of this pyramid and iterate horizontally. So what does that mean? You have to get something working end to end, from the data collection, the data storage, cleaning the data, and then starting to deliver value with the data. So you can choose one or two tops use cases that would be most valuable to the company, and start there and get it working end to end automatically. Get that workflow automated, and then start iterating horizontally based on the priority of the other use cases. What will this provide for the team? Well, the data scientist will understand how to actually go work with a project end to end, from the data collection pipelines all the way to delivering the output of the data. It may be a prediction, or it may be a dashboard, or just reporting KPIs. And when you iterate horizontally, that means when you're in the next iteration, you're going to be able to work a lot faster through all of these steps, and that way you're going to be scaling your operation, the data science operation, with more data, more use cases, and every iteration will be faster and better than the last one. This really makes this kind of well, yeah, organization between data engineering and data science makes it very important to get the fundamentals right. So if your data flow is kind of shaky, if your data quality isn't really that great, and you can't really rely on the you can't rely on the quality of the data, then it's going to be very hard to get to that point where you can start looking at machine learning use cases. Also, well, with regards to the good practices that we looked at with working in a team of data scientists, here in a new team of data scientists, it's even more important for each data scientist to be responsible for these good practices. Sometimes when you get to a team that's already established, there's some tools, there's some policies that won't let you, make a merge request to the code base or deploy a model if you don't check the boxes on certain policies and certain things with your code or with the comments and documentation, for example. But here, in a new team, you have to really be responsible for this. Otherwise, if you start deploying models without any comments, without any documents, and without monitoring the model in production, then it's kind of like the first practice that you're putting into production, and it's not going to be something that you're going to be able to scale into good practices. So you have to start from day one with this. And finally, with new teams, well, you guys are building new stuff, right? So being forward thinking is very, very important. There's a lot of new technology that is coming up, a lot of paradigm shifts that are happening in these last few years. And so if the team is in charge of building the data infrastructure, well, maybe if you start working on a data warehouse, maybe an on-prem data warehouse, maybe that be a little bit outdated. Maybe you can consider cloud services for your data warehouse. Maybe you can start thinking about more flexible data architecture, such as a data lake. And most recently, well, I'll maybe get into that a little bit more later. So the ultimate objective on this is, going beyond the tech skills of the data scientist, is to contribute your work, contribute code, contribute practices, so that the team can scale reliably in an agile form. Okay, so now moving on to imposter syndrome. So it's important for you to remember that working in data science and perfecting your data science practice is a work in progress always, and it always will be. The data science field is a new field where people don't really know how to define it yet. There's some people that define it one way. There's a few people that define it on, maybe including something on the DevOps side or the data engineering side. So that makes data science prime ground for the flourishing of insecurities. So one of the also data science is a combination of fields, right? So, and these fields are sufficiently deep by themselves already. You have computing and software engineering, you have mathematics and statistics, and all of the business knowledge and business know-how. So it's perfectly reasonable for you to be lacking some knowledge on any of these individual fields. And lastly, data science is in constant expansion. So just like anything tech related right now, it's in constant expansion really, really fast due to cheap computational power, cheaper computational power from the last years. And storage, also cheaper storage, having this paradigm where you can store things on the cloud and then decouple computing from it, so that's kind of a data lake architecture. That really has changed the paradigm for data and data science, and that's why it's really taking off right now. And finally, open source projects in data science really makes data science more accessible and does a lot of work to advance the democratization of data science. So every data scientist is learning on the job. That's kind of like the basic rule. My advice would be get used to Googling. Most of the time, I've seen people struggle and being stuck at certain parts of their development or with the machine learning code or getting data properly prepped. And you could solve it with the right Google search. That's the solution, right? Instead of kind of feeling stuck and maybe going over your notes, not understanding the documentation. If you know how to Google it, you're going to find it. That's true from the most junior data scientist to the most senior data scientist in any organization. Also, I think it's very important for you to accept that you will never be able to learn everything. You're going to be start learning a lot of things in your first data science job, and when you start working with other data scientists, you're going to learn a lot of things from other data scientists as well. But it's very difficult to learn everything. So that's a very important thing to accept. And also, something you have to accept is that you guys can contribute in ways that no one else can. Nobody else has your combination of background. Nobody else has your combination of skills. So maybe you have something in your training experience or further back in your bachelor's, where you maybe looked at the problem that nobody else looked at it that way, and now that you have these technical skills and have data in front of you, maybe you kind of take an approach that nobody else would have thought about. So that's really important. That's really helped me with understanding that I have ways to contribute to data science that no one else can. And well, one of the most important things that I did, I think, to help me get into onto the same page and with the latest cutting edge technology in data science, is to get myself into the data science community. I think that's one of the biggest recommendations I can give you guys. Get a Twitter account. If you guys use Twitter, maybe make a second Twitter account and curate it so that you follow data scientists in companies that you admire, maybe statisticians that that publish books. So that really helps out for new data scientists to start looking at what senior data scientists and leading data scientists are actually asking. And you can see most of the time, some data scientists will actually ask questions on their Twitter, and there may be questions that you actually are struggling with yourself. And you kind of see that in these leaders in the industry, and you find out, oh, okay, so like this is an actual problem, that the problem I'm having isn't a problem I should be disregarding. It's a problem that is common in the industry, and it's a challenge that data scientists have to work to solve, right? So also, I would recommend you guys open a Medium account. Medium account, there's quite a few tech and data science blogs on Medium. For example, the Airbnb technology blog is very good, and also the Square data science blog is excellent. And you get a lot of content there. You have from gentle introductions to a certain topic or a certain module in Python to deep dives into how an XGBoost algorithm works, how performance metrics have to be calculated with imbalance classification problems. And you actually get most of the time, or half of the time, you get the code snippets to actually work the project as well. So there's a lot of things in Medium that are really helpful, not only on the data science side, but also demystifying all of the cloud architecture, data engineering, all these new other technologies that aren't exactly for data science, but are kind of present, say Apache Spark, Apache Airflow, all the AWS cloud computing services like Lambda. So that's a really good source to get the know-how. No. Also, cheat sheets. Cheat sheets are very good to get yourself started. There's a lot of cheat sheets. I remember a few from Stanford on machine learning and deep learning as well. Those are very, very good cheat sheets, more on the theoretical side, but you also get cheat sheets for R, for ggplot, for Python, for Spark as well. Those have really saved my life. And the point here is not only to stay with the initial cheat sheets. Is the really powerful stuff is when you start creating your own cheat sheets for yourself. So when you start to identify that you're always going back to a certain part of a cheat sheet for a certain module, or that you're always using a certain piece of code, you open up. I like to use a tool called Notion, where you just write down, okay, Python cheat sheet, and you start writing down all the functions that you constantly use, and that's kind of like your mini toolkit, so that when you're working on a problem, you just go there, you open up your cheat sheet, copy paste, and that's it. You don't have to memorize everything. You know everything that all the functions that have been very useful and have gotten you out of a huge problem, that you didn't know how to tackle. You can put it into your cheat sheet, and that's really helpful. Also, when you finish a big data science course, such as the NYC Data Science Academy course, it's also a very good way to take a look over all the content that you looked at. It's going to be a lot of material, so it's very good to actually start to pick and choose what functions and what part of what code can be really useful and is really useful for your projects. So I would recommend you go through that. And finally, keeping relevant email subscriptions. I think one of the best subscriptions I've had is KD Nuggets, this data science blog that shares a lot of relevant blog posts and advances in machine learning and data science field. Okay, so now moving on to data engineering. Okay, I'm not sure how much time we have left. Let me just.
Okay. It's around 4, so you
Okay.
can you can decide, and we have a few questions, so
okay,
maybe at the end. Yeah.
Awesome. So real quick, data engineering. Data engineering is something very important that sometimes in data science isn't. It's kind of pushed aside. This is one of my favorite definitions regarding data science and data engineering. Data science is the discipline of making the data useful, and data engineering is the discipline of making the data usable. So this is very important because when you say you're the first data scientist in the company, they say, okay, want to do data science, and then you get there and there's no data. There's data everywhere. You don't know where to get the data. So the discipline of data engineering is very important for data science to actually scale and perform well in the company, right? So I'm going to go through this a little bit quicker. Never take data as a given. That's really important. Always stay close to the data engineering side. So say the data cleaning process in data science is made a lot easier by data engineering. Data science won't scale if there's no data engineering. Data engineering has to centralize data, make the data useful so that data science can actually do their thing. Good data sets are as valuable or even more valuable as good models. And as you can see, what I have here on this diagram right on the right is so data infrastructure is what data engineering does. It centralizes data, makes data usable, but on its own, it really doesn't really contribute any value to the company. The value starts to increase when you start to deploy and create analytical solutions, right? So making data-based decisions, that's the first level of value, and then the value really explodes when you start to operationalize the data and create operational solutions with the data. Okay, so finally, just talking about really quick about the tech. What I'm showing you here is this work that's been done by the website A16Z. It's a unified data infrastructure architecture where it gives you the big picture of where data science fits in the entire tech stack of a company. And data science is kind of just locked in here. There's a lot of data ingestion, data transformation, data storage technologies that have to be used, and data sciences uses this the data infrastructure to perform and to deliver value, right? So it's important for for the data scientists to also start getting a grasp of the technology and where they fit. The people in the data science team that are most valuable and that contribute the most value are the people that understand the tech, that understand the data flow and understand what kind of machine learning and data solutions are viable with regards to the architecture and the tech stack. So a few architectural shifts. I'm gonna just hone down on one. First of all, there's this new architectural shift during the last couple of years, where there's this next generation data lakes coming into the industry. They're leadered and pioneered by Databricks, Snowflake, and Presto, where there's this new paradigm called the data lakehouse. If you look at the history, data warehouses are very old, like they come from the 80s and 90s. Then the data lake paradigm comes into play when the cloud and computing starts to get decoupled. And finally, right now, what we're looking at is new paradigms of data lake houses, where you take the benefits of both worlds into a single place, and that really makes life easier for data scientists and data engineers. This also comes from the A16Z blog. And finally, in the long run, and talking about perfecting your data practice, it's about iteration, it's about habits. Stick to good habits from day one. Document, comment your code. Those are the most important things you can do as an individual contributor for a code base in the team, or even for yourself in a single data person organization. Document for your future self, comment and write functional code for your future self, as well as in a team for your collaborators, right? Understand the data flow, understand how the data that you're using actually gets to the point where you start using it. If it's something that comes from a streaming architecture or a batch architecture, understand how the data is collected. It may be manually filled out. That's also really important for you to identify what the most valuable use cases and how you should interpret that data for your machine learning models. Cross-pollinate with other data scientists. This is a term that relates to understanding and learning from other data scientist skills, which is very valuable. You're not going to be able to learn everything. So if somebody else already learned it for you and they can explain it to you, that really is of huge value. Stay close to the engineering. Don't disregard data pipelines and data pipeline technology, ETLs and ELTs. And finally, get comfortable with the tech. The tech is where everything, all of the data infrastructure is going to live. It's going to be where you deploy your models. It's going to be where you monitor your models. So get comfortable with the tech. Demystify these cloud services. That's going to be very useful for you when you start working in a company with the data infrastructure in the cloud. And so finally, just a closing remark would be, what you can do no matter where you start working in data sciences as a data scientist is to create an environment where you bring good data science practices into play to the point where the team can deliver faster and better with each iteration at large scale. So that's not going to be just for you contributing a very good model or a very cool visualization. It's going to be contributing to the team, to the organization, to make data science one of the most important value sources for the company. So that's it. Thank you very much. Thanks so much for your attention. I think we're going to move on to your questions now.
Okie dokie. So first of all is asking, learning on the job. How much of your average week is learning new skills? Is this formal or on demand?
Okay, so I think it's more on demand than kind of formal or having a habit of it. I think I have to be better personally at reserving some time for training and taking some online courses. Usually it's more on demand depending on the use case that we're discussing what the best solution would be in regards to to the data flow, for example, or the model that we're going to use. That usually is more on demand. So Twitter is a good source for inspiration, but Medium is more is made for the deep dives to understand how you could deploy a model with API gateway and Lambda. There's a lot of use cases like that. So I think if I would have to say a percentage of how much I learn on the job, I would say 50%. If you're not really learning it at the job, then maybe you're not in the right place.
And saying, could you please share the time distribution you spend in a daily work as a data scientist? For example, 40% on data cleaning and processing, 10% communication. Like, what's your day?
So I think I've passed through quite a few different organizations and ways of working. I would say in a one-person data organization, a small data operation, I would say 80% would be finding out where the data comes from and where I can get my data. That's a lot of work, talking to different stakeholders, understanding how they use the data to make decisions. And then the next thing I would say takes most of the time would be prepping the data, getting the data, moving the data to where you need it, and finally, just 20%, maybe I said it wrong. 80% tracking down your data and getting your data. That would be 80%, and the other 20%. Analyzing, doing the analytics, testing out machine learning models. I think that would be kind of fair. Getting the data visualizations as well. And in a team, I think that the data engineering in a team that already has a data infrastructure in place, well, that really helps the data scientists start to use more of their time on the analytics and on the data, the exploratory data analysis and the machine learning development. So I would say in a team with the data infrastructure more advanced, I would say 60%. It's not going to be ever going to be less than half of your time. At least 60% working the data, getting the data in the state that you need so that you can get your training set and train your model. Mm-hmm. And the rest of it would be analytics and also the deployment, right? Yeah. And finally, nowadays I think I'm more talking with stakeholders and understanding how to get our data into usable states. Right now that we're starting out as a new team, right now I think if I would have to say over the last year, 98% of our time has gone into getting the data in a usable state, and just it's going to be start to shift towards the use cases of actually getting some value out of the data.
Interesting. Okay, another Sierra asks, from your explanation of hierarchy of needs, can you give a specific example of a vertical cross-section, then iterating horizontally? Maybe did you use this in one of your projects?
Yeah, for sure. So say in financial institutions that do loans, it's very important to see how the quality and how your portfolio of loans is performing. So there's a report called Vintage Analysis in the financial and risk departments in these kind of institutions that is basic, that they have to be looking at and monitoring every month, every 3 months, and it's not that easy to compute and calculate. So what I started working with, I started out with getting the data by email. Then I talked to the people that actually sent those emails with the data. I connected to the databases. I did all this in R. and I started to automate all the data flow. And finally, I think the code would be 90% of joining all of the data that I got from these different data sources, processing the data, and then the last 10% would just be computing and these vintage metrics and plotting the graph. Like that would be a vertical cross section. Plotting the graph would be the end of it. It would be maybe sending the report via email or creating a table that could be queried using Power BI, for example, or a BI tool. That would be a end-to-end workflow. After that, say if you stick, I think that the best case scenario would be to stick with the same use case. Would be the next step would be the origination model. Actually, that's the order it happened for me back then. The next step would be, okay, now that I understand how delinquency and non-payments work with our portfolio, now that I have the data flow automated, now I can start to prep my data and start the feature engineering part to create features that would inform which clients or which customers are going to default. And so then the next iteration started out with the same data flow, some more data prepping and feature engineering, then the machine learning development, and finally the machine learning monitoring. And that's when that was the second iteration closed.
Wow, that was like really deep. Okay, so there's someone asking, I'm curious about your previous experience with the mortgage loan you mentioned. Can you tell me more about your experience related to data science in those particular area?
So with mortgage loans, it's been kind of different than my previous experience, which was SME loans, loans for small and medium enterprises. Because mortgage loans are very much longer term. So the tricky part is getting the target variable right for your machine learning model. In any loan use case for machine learning, you're going to have an imbalance classification problem, and depending on the nature of the financial instrument, you're going to have a severely imbalanced classification problem. So that's going to be certainly a challenge for the data scientists developing the machine learning model. And in the case of mortgage loans, you have to be mindful of the risk that you want to actually model. So if it's a mortgage loan that is 20, 30 years long, maybe if you define your target variable as only say 10 days, 15 days of delinquency in the first 6 months, well, maybe you're going to have a very, 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 very tiny approval rate. So that's where you have to talk with stakeholders, with the credit team, with the risk team, so that you guys can be aligned in the type of risk that you want to model, and so that the approval rates that you actually see with your model in production make sense with the financial product you're offering.
Okay. Any other questions in general? And just in case, yes, we're gonna share the recording and the slides if you guys want it. And thank you so much, Raúl, for giving this talk. We learned so much, and also thanks for all the resources you shared. And if you guys are interested in more events, next week we're gonna have Choosing Effective Data Visualization, and it's gonna be presented by one of our instructors. And in case you guys are interested in our bootcamps, our next cohort start on November 8th. So feel free to check our website and see all the offerings.
Awesome.
Thank you so much.
Thanks so much, everybody.
Any other last minute questions? If not, thank you again, Raúl. It was really nice meeting you. And
yeah, you too. Have a good day.
In case you fly by New York, feel free to swing by our academy again.
Oh, for sure. I wanna go back.
Yeah, it's really worth it. Okay, I'm gonna close it. Bye, guys.
Thank you. Bye.
Bye.